Hello and welcome to section 12.6. We're going to be talking about the volume and the surface area of the sphere today. Sorry about that. Lost my train of thought. Here are the answers for 12.6. Again, as always with this chapter, you may have solved the problems a little bit differently. That's okay. Okay, here's your vocab as most sections start off with. Sphere is a set of all points in space equidistant from a given point. It's basically the same definition as a circle, only in a given, instead of in space, with a circle we deal with on a plane. And then we have our radius, we have a chord. You're not really going to see chord very often. You have your diameter, all things, is all really, basically it's circles with 3 dimensions. Okay, I'm just going to get into the formulas here. There are 2 formulas. Surface area is 4 pi r squared. So basically it's pi r squared, the area of a circle, times 4. There's a reason for this. You're going to discover this reason when you get to calculus. I'm not going to get into that. We're just going to go with the basics today. So here we have an example. They give us the surface area. They want to know the diameter. So what we're going to do is we're going to find the radius, and then we're going to double that. So 20.25 pi is the surface area, and that's equal to 4 pi r squared. So what I'm going to do is I'm just going to solve this equation for r, figure out r is, and then double that to get my answer. So I'm going to divide by pi, those are gone, and then I'm going to divide by 4, so 20.25 divided by 4 is 5.0625, and that's equal to r squared. We'll square root that answer. And then that's 2.25, and then I'm gonna double that to get the diameter, so 4.5 centimeters. This is a great circle. It's basically if you do a cross section and it contains, sorry, I'm just gonna read this. If the plane intersects a sphere, the intersection is either a single point or a circle. If the plane contains the center of the sphere, then it's a great circle. The circumference of a great circle is the circumference of a sphere. Every great circle splits it into 2 hemispheres. You really don't need to know this. You just need to know what a hemisphere is. A hemisphere is basically half of a sphere. Like I said, you don't really focus on that. Just know what a hemisphere is if you see that word there. And then we have the formula for the volume of spheres, 4/3 pi r cubed. I'm not going to get into why this works the way it is. I'm just going to do a problem for you guys. That's the formula that you need to know right there. Pretty straightforward here. So here's the example I chose. Find the volume of a composite solid. What this is, it is a cylinder minus a hemisphere. Okay, so what I'm going to do is I'm going to find the volume of the cylinder, then I'm going to take away half of the sphere. So the cylinder is pi r squared times h. So base is a circle times the height. So pi r squared is 4, the height is 2, so I have 8 pi for the cylinder. Now I'm going to take away 1/2 of a sphere. So 1/2, 4/3 pi r cubed. So r is 8, so 1 times 4 is 4, 2 times 3 is 6, and then pi, and then 8, because the radius is 2. Okay, so I have 32 pi over 6, and that reduces to 16 pi over 3. So my final answer is whatever this may be. And there you go. So that's basically it. Here's your assignment. And I actually just changed the assignment here. I made a few of these problems more challenge problems, or just like extra bonus problems, just to kind of keep the assignment shorter for you guys. So there's your updated assignment. Thank you.